Hi everybody, this is the continuation lecture on SSB question solution. In our second lecture, we had completed up to the 10th number question. So in today's lecture, let's start from 11th number question. So the 11th number question was integration minus 1 to positive 1 p naught x dx, where p naught is a polynomial, Legendre polynomial. Okay, and its value is, if you see the solution, its value is 1, p naught x is 1. Okay, so integration minus 1 to positive 1 1 dx is nothing but dx integration, so its value will be x from minus 1 to positive 1. So ultimately it will give you 2. Now coming to the 12th number question, it was given a unharmonic oscillator, and it has given a Lagrangian, and the Lagrangian is this. The Lagrangian is, this is the Lagrangian we are given. Okay, and it is asked to find the Hamiltonian. So what you have to do, you have to see, if you see the solution, we know from the Jacobi integral that S, that means the Hamiltonian is summation qi dot p minus l. Okay, so what you have to do, we have to first find the generalized velocity. Okay, so how to find the generalized velocity? We can find it from del l by del x dot. Okay, so if you do the derivative of this quantity, partial derivative, then you will get x dot plus 2p 2 beta x x dot, and you will get the generalized velocity value as p by 1 plus 2 beta x. And if you substitute this value in this expression, that is equation 2, then you will, and after multiplication or addition, subtraction, division, simple math, you will get the value of h as this. Okay, this is the value, this is the Hamiltonian value, so option B is correct. Now coming to the 13 number question, the question was about commutation. So L square, that is the total angular momentum square, and Lx. So what is the commutation? The commutation is 0. Okay, so now coming to the 14 number question, the question was about the phase difference between the modulated amplitude of two coupled pendulum. Okay, so what is coupled pendulum? If you disturb something, some participant in some, let's suppose this is a combination of two pendulum. If you give a force to any one of the pendulum, then ultimately that force will be transferred to the other pendulum, or you can say the energy will be transferred to the other system. Okay, so there is a sharing of energy, or we can say the amplitude. So now if you see the solution of this 40 number, then it is like something. To know the solution, you should have a background knowledge of this coupled pendulum system. Here x is the displacement in the first pendulum. This is the first pendulum, this one. Okay, and this is the second pendulum, and this first system is in phase system, and the second system is out of phase system. Okay, so in phase system means the both pendulum are moving in the same direction, but whereas in the out of phase oscillation, both pendulum are moving in opposite direction. So it is the second condition is out of phase, that means there is a phase difference of a pi, and the first system, that is in phase oscillation, there is a phase difference of 0. Okay, so this is the pendulum displacement. First pendulum displacement is denoted as x, and the second pendulum displacement is denoted as y. Okay, so now coming to the, there is a some theoretical basis of this question. If you know, then you can answer, otherwise you cannot. Okay, So please see this solution. The solution is like this. The x, that is the displacement in the first pendulum, is can be written as 2a cos omega m t and cos omega a t, and y is like this, 2a sin omega t and sin omega a t, where this omega m is omega 1 minus omega 2 by 2. This is the modulated frequency, and where is this omega a is omega 1 plus omega 2 by 2. This is the average frequency. Okay, so otherwise you can see that we can also write this x and y in this term, where a1 is the modulated amplitude for the first pendulum and a2 is the modulated amplitude for the second pendulum. Okay, so now as we are asked to find the phase difference between the two modulated pendulum, if you see the graph, this is the graph. Please see this envelope only. This is the greenish part envelope. Don't see this highly frequency oscillating system. Don't see this. You only see this envelope, how it is propagating. Okay, so this system is for the total x, that means the displacement in first pendulum. Okay, you don't see that part, you see only this envelope, the bigger envelope. This kind of system is, you can see in group velocity, like that. Okay, so this envelope has the equation of 2a cos omega mt. This is for first pendulum. Okay, this is for first pendulum, and this is for second pendulum. If you see that for first pendulum, this is the amplitude is start at 0 equal to 0, at this is the t equal to 0, this is the t equal to 0 time. At t equal to 0, the first pendulum is at maximum amplitude, that is at 2a. Okay, this is 2a, and at that particular time, that is at equal to 0, t equal to 0, the second pendulum is at as an amplitude 0. That means, as you know that in classical system, in classical mechanics, energy is proportional to amplitude square. That means whatever energy we have given to the system, that is the coupled harmonic system, that is stored at this time at t equal to 0 at in the first pendulum, and there is no energy at this time at t equal to 0, because its amplitude is 0. Okay, so the first pendulum has total energy. Okay, so now if you see this amplitude, it is at t equal to 0, it is at maximum, whereas at t equal to 0, this is at minimum. That means what? That means these two amplitude are at phase difference of pi by 2, means 90 degree. It's obvious. If you see this, if you see the this these two equation, if you see these two equation, you can find that these are at a pi by 2 phase difference, because it is in cos and it is in sine. Okay, so now coming to the number 15 question number. So it is asked to find the energy, it is asked to find the time period between the twice flow of energy. Okay, so now that was I was talking little bit before. The thing is, if you see the graphs, amplitude is energy is amplitude square in classical system. So if you see that at this position at t equal to 0, the energy is stored in full energy is stored in pendulum 1, whereas at t equal to 0, there is no energy in pendulum 2. But at a t equal to pi by 2 omega m, the first pendulum has lost its total energy, and the whole energy has transferred to the second pendulum, because its amplitude is at a high. When the amplitude is at a high, that means the total energy is shifted to the pendulum 2, because its amplitude is at 0, first pendulum. Now this is for one cycle of flow, of energy. Now for the second flow, that means when the total energy that those are which are stored in the second pendulum transfer to the first pendulum, and it will take place after another pi by 2 omega m time. So ultimately how much time it will take for a twice flow of energy, that was asked in the question. So the total time, that is capital T, should be 2 times of pi by 2 omega m. Okay, if you see the solution, okay, this is the solution. If you see this, the total time should be 2 times of pi by 2 omega m, and omega m, you know that omega m value, omega 1 minus omega 2 by 2, so it will be 2 pi by omega 1 minus omega 2. But in the question, in the solution, in the question, the options are 2 pi by omega 2 minus omega 1. That is not a different. Okay, it is the same case. Okay, the answer is same, because you don't know what which value is larger or which value is smaller. So the answer is option D.